In previous videos, we was learned FET, JFET and differences between BJT and FET. So actually what is FET and JFET? Field effect transistor and junction field effect transistors is one kind of transistor. Its actually applications are similar to BJT, but its working principle is kind of different from BJT. So in previous video we discussed about FET, and now this video we discuss about JFET. So JFET is a one kind of transistor like BJT, but its working principle is different. So let's talk about, this is a symbol of BJT, normal NPN transistor, where this is a NPN and this is a PNP. So this is a base terminal, collector terminal and emitter terminal. Similarly, this is a base, collector and emitter. For NPN transistor, arrow is always outside, and for PNP transistor, arrow is always inside. This is a BJT. But now we are talking about JFET, N-channel JFET and P-channel JFET. So this is a N-channel JFET symbol and this is a P-channel JFET symbol. So this is a gate, drain and source, and similarly this is a gate, drain and source. In these two symbols, for N-channel JFET, arrow will be inside, and for P-channel JFET, arrow will be outside. So now we are talking about, this is a symbol, we are talking about diagram, like block diagram. So this is a block, so this is a gate, drain and source. In here this is a input side, in here this is a output side. For input side we are measure VGS, and for output side we are consider about ID current, which is drain applied between drain to source. So this is inside diagram, this is gate, drain and source. Be here, we all know that in FET and also similar to JFET, two PN junctions are inside here, and for that these two P types are identical, that's both are connected inside. These two P are identical, that's they are connected both inside. So this is a source, drain and gate. So now this is a N-channel JFET and this is a P-channel JFET. How we find out how it is N-channel or P-channel, I was discussed in previous video. So let's see, this is a P-channel, P side, and this is a whole block is N side. This is a P side only, these two sides, and these all are N sides. So when we applied some power supply or when it construct, so normally the PN side, the depletion layer is established. So how? When it construct, the P type and N type is established a depletion region on both sides of P type. So here is a depletion layer, it established a depletion layer. Now this is a symbols. Now we are talking about, in this video we are considered about N-channel JFET. So this is a N-channel JFET. So how it's work? At first in here I connected D and S, means with a battery, and through this battery the voltage we get it, that VDS means voltage between drain to source. So at first I connected a battery with this drain side and source side. So the point is, battery's positive potential is connected to the drain side and battery's negative potential is connected to the source side. So in this side we get a voltage, that is VDS. So ID current is depend on potential difference of VGS gate to source. Okay. So now in here we are considering two forms, like VGS equals to 0 volt and VGS less than 0 volt. in two conditions. So at first in this video I will discuss only this condition. The next video I will discuss this condition. So in this condition, here must be VGS equals to 0. Then how? I just connected the gate terminal to source terminal, and then source will be grounded. If source will be grounded, then the potential difference of VGS equals to 0. So the connection is very clear, which is a battery is connected to the drain to source, and battery positive side is connected to drain and negative side is connected to source. And also we want VGS equals to 0, that's why we connected gate to source, and source will be grounded after. So in that case, this is a P side, this is a N side, and this is a depletion layer. When it construct, then depletion layer is established. Now the direction of ID current, the direction means now the flow of current will be drain to source. The flow of current will be drain to source. Why? That's positive terminal will be connected drain terminal and negative terminal will be connected source terminal. That's why when we applied VDS, so drain is higher potential and source is lower potential. That's why the ID current is flow in this direction, drain to source, because of this. I hope you all understand. Now suppose VDS equals to 4 volt. Okay, so when we all know that VDS equals to 4 volt means VDS equals to 4. So positive terminal is connected to drain and negative terminal is connected to source. Then if I'm say that VDS equals to 4 volt, then I can say that D equals to 4 volt and S equals to 0 volt, right? Because S is grounded 0 volt, and because of positive potential is connected to drain, then if VDS equals to 4 volt, then drain equals to 4 volt. Then we understand the 4 volt is becomes a decrease slowly. That's why S equals to 0. But how it's working? Let's hear. Suppose this is drain equals to 4 and source equals to 0. But in here, I can say that if this is 4, then this is 3 volt, this is 2 volt, this is 1 volt, then it's slowly 0. Gradually it's 0 volt. Then I can say that if this types of application it's happened, then I can say easily for the upper portion is positive potential, lower portion is also positive potential, but compared to this potential, upper portion is more positive compared to lower potential. I can repeat again. From drain to source, the potential becomes slowly to decrease, right? Drain to source, the potential becomes slowly decrease. This is a 4 volt, 3 volt, 2 volt, 1 volt as 0 volt. And now here P side is connected. So in that case, slowly decrease. So I can say that for upper portion, positive potential is more powerful compared to this positive potential. Yeah, of course, this is a 3 volt, this is a 1 volt, so this portion is more powerful. At that situation, suppose P side is connected to the potential. So here P is connected to the negative potential because this is grounded, this is 0, VGS equals to 0. That means P side is connected to the negative potential and N side is connected to the positive potential. At that situation, when P is negative and N is positive, then we can say that in here reverse bias is happened, that P side is connected to the potential and the negative potential and N side is connected to the higher potential. That's reverse bias is happened. And when reverse bias is happened, the depletion layer is increased. If depletion layer is increased, then the depletion layer is increased right this way. But for the upper portion, reverse bias is happened more. compared to the lower portion. লোয়ার পোর্শনে রিভার্স বায়াসটা কম হবে compared to upper portion. That's why the depletion layer is more wider compared to the lower portion of depletion layer. That's why, so that the upper reverse bias is higher compared to lower side reverse bias, so upper side depletion layer is more than the lower side depletion layer. So I hope this operation is understand to all. Then I say that this VDS is variable. Variable means I can change it easily, either increase or decrease. So suppose now VDS is variable, so VDS equals to 8 volt. When VDS equals to 8 volt, so if we increase VDS, the depletion layer will be increased. Of course, if it is increased, the depletion layer will be increased and channel will be reduced. Channel means the free electrons flowing channels is reduced. For standing, when we applied VDS and we increase it, when we applied VDS, of course we applied VDS and we increase VDS, its value, then that time current will increase. That time when we applied VDS means 8 volt, that time current will suddenly increase. But when the depletion layer is increased, means this layer is increased, that time the current ID is slowly decreased. So at that time, when VDS is increased, suddenly ID is increased. But when the channel thickness will be reduced, means this channel thickness will be reduced and resistance it increase, that time ID is decreased. So with the time situation or condition, ID will be saturated. Okay, so at a time when we just increase VDS randomly, then at a time that ID will not decrease, it will be saturated, will not decrease or increase, it will be saturated. And that time depletion layer is weakly increased, depletion layer is heavily increased, and the channel is totally narrow. So this is a note. Always remember, these two depletion regions never touch each other due to electrostatic repulsion. So these two depletion layer never touch, it's always have some space. So this process is happened at a voltage when ID is saturated. So which voltage ID is saturated, this voltage is called pinch off voltage. Very important to everyone. Always remember, it's a question that given in exams, that ID current is saturated by which voltage, then you all say that this is pinch off voltage. So this is the output characteristics. This curve is represent VDS volt, and this axis is represent ID, and this axis is represent VDS. So at that situation, this is a ID saturate. So at that situation, when voltage is 0, no current will flow. But when voltage is increased, then the current will increase, I said before. Then at a point when your current will be saturated, at a point when your current will be saturated, at that time ID equals to saturated, and this point will be noted with this is ID saturated point, and this axis, this point is VP, means pinch off voltage pinch off. So this is a output characteristics of pinch off voltage and output characteristics of JFET. For first condition, means VGS equals to 0 volt. In the next video, I will discuss VGS less than 0. Thank you. I hope you all understand. So please subscribe my channel and share and like. So I need it more.